Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, Dota Senate. So basically what this problem says is that we have two parties, Radiant and Dire, and we have senators from these two parties, and now they want to decide on a change in the game, whatever. But essentially, what happens is we have rounds for this game, and each round, each senator can exercise one of the two rights. Which basically means there are two options: either senator bans one other senator's right, so of course they ban only the other party. So let's say one senator of this R bans the one of D, or the one of D bans the one of R, right? Otherwise, just announces the victory, and this happens if the only senators that still have rights to votes are of the same party, right? Because remember, one senator can ban another from voting, so we can arrive at a position where only one party has votes left, and so in that case we can announce victory. Okay. Now we get the string representing the Senate, so basically represents what each senator's party is, with the character R and D. And the goal is we can do rounds, right? Basically, it circulates. So let's say, for example, if we have here R and then another D, right? This D can ban this R, for example. Okay, this R can ban this D. So you get the idea. It can be in the next round. It goes back, and we want to suppose that each senator is smart enough and will play the best strategy for his own party. Okay, and then we want to predict which party will announce the victory first, which basically means which party will have like only the senators from that party left. Okay. I know it's very wordy. It's complicated a little bit, the description they gave. That's why thumbs down here. But let's explain it and see a little bit here. So what happens with this one? Well, this senator, right? Because he is first, they can just ban this one. Okay, so they ban D, and now the only one left is R in the next round, and so only one party left, so we return Radiant. Now in this case here, again, this one, since it's the first one, can ban this one. Okay, and so in the next round, this one, D here, bans R, right? Because we go back, and so now what's left is only D, and so we return Dire. So you get the idea. Now let's see how we can tackle it here. We have up to 10 to the power of 4, so this tells us that we should aim to solve it in something less than O(n squared. So let's see how we can tackle it. Okay, so let's see how we can handle this. So let's take, for example, DD RR like this. So what happens here? Well, what's the optimal thing to happen here? Well, for these, they should just remove the vote, right? Or ban the R's after them, right? And so let's say this one bans this one bans the closest one here. And so what happens to these, right? Once they ban it? Well, once this bans this one, it needs to go back to the end, so that next round we can run it. You can think of it sort of that way, so that basically, what happens here, if we do this like step by step, let's say D, D, R, R, R. So what happens first is that this one bans this one and then goes to the back, right? So it goes here, and so that basically gives us D, right? This R here is removed. So we have R, which is this one, and then we have this R. Okay, and then we need the D back here. Okay, so you can see overall we just removed one R. Okay, then the next step, well, this one, the front again, removes the next one, and then it goes back here. And so now what do we have? We have the R here, and then we have this D, and then we have the new D here. Okay, so what happens in the next round? Well, this one, right, removes this one and goes to the back, and so now we have D, R, sorry, we have, yeah, just DR, right? And now what happens again? Well, this one bans this one, and now we have only D left, and so now we return dire. Okay, and so what did we do here, right? If we think about a little bit what happened, well, we just, of course, we know we need a queue, because what happens is that every time we used one, we put it in the back of the queue for the next round. Okay, so we know we need a queue. That's the first thing. Because queue, it's easy to pop left and then append at the back. Pop from the front and append at the back. Okay. Okay, so we need a queue for that functionality, but the other functionality is that we need to know, for R, we need to know if there was a D before, and for a D, we need to know if there was an R before. So let's say we had something like this. What matters to this D is if there was an R before it or not. Now, if we have multiple Ds, what matters is how many R's before, right? Because here we have R 3 times, and so that means we can kill this and still have 2 left, and kill this and have 1 left. But if there was just 1 R, right, then when we kill this, we have 0 R's left, so this one doesn't get killed, or doesn't get banned. By killed, I mean banned. So what matters also for each one of them, right? So for R's, what matters is the count of the D's that before it, and for D's, the count of the R before it. So we need 2 variables. One, let's call it R before count, right? And then the other one, let's call it D before count. Okay. So with these 2, we should be able to just to do it case by case, right? Now, when are we done? Well, from what we saw here, we are done when there is only one party left, right? So how can we check that? Well, if we just take the queue, and convert it to a set, right? Then if the length of the set is bigger than 1, that means there is more than one party. And so we can continue as long as this is happening. But once this is no longer the case, which means there is only one party in the queue, then we can stop and just return the party that is in the queue, right? So let's run it actually on an example here. Let's run it on that DD R R R. Okay, so our queue initially has all of these, so it has initially D D R R R. Okay, and initially with those 2 are 0, right? So okay, and so initially we are here, we have this D, right? There is no D nothing before it in R, and there is no R before it, right? So it doesn't get killed, right? And so that means we just add it to the back and say we have a D now. Okay, so that means basically we remove it from here, we add it to the back of the queue here, and we say now that we have seen a D. Okay, and then we pop from the left again. Now we get a D, and so we check if there was an R before, because if there was an R before, that means it is banned, right? But there wasn't, because it's 0, so it's fine. Then we can just put this at the back for the next round and say we have 1 more D. Okay, and now we pop from the front again, so we have an R, and now R, this is important because now we check if we've seen a D before, and yes, we did, and so this one gets banned using this one. And so once it gets banned, we should subtract -1 because we just used 1. You can't use the same senator to ban multiple times in the same round. You have to use it only once, and so we have to subtract it by 1 here. Okay, and this one we don't add it to the back because it's already banned, it's done, right? And so we remove it, and now we pop from the front again, we have another R, so we check if we have D before count. We do, we have 1, and so again we use that one to ban it, and so we subtract again, now it's 0. Okay, we don't add it to the back because we banned it, right? And now we pop from the front again, we have an R. Okay, and now since we have an R, by the way, also I didn't increment the R before count here because those were banned, so we shouldn't increment. They are banned. And then here, when we come to this R, right, D is equal to 0, D before count, and so we remove it and we put it here, and we increment the number of R before count. And now we continue, now because we have elements, now we check the D. Is there an R before count? Yes, it is there, one here. So we subtracted by 0, and now we can remove this one. We don't add it to the back because we banned it, right? And then we pop from the front again. And so, and we notice here we didn't add it to the D before count. And now when we pop from the front to this one, we add it, right? Because it's not banned because R before count is 0. And so we put this back to the end. We remove it here. And now, now we check out for this R, is there a D before count? Yes. And so we use it, it becomes 0, we ban this one, we don't add it to the back, right? And now our while loop will end because we have only D in the queue. And so we stop and we return the one that is left in the queue, which is D, which means we will return dire. Okay, and that's the idea here. I hope that was clear. So we just used these two variables in the queue and that should solve it for us. Yeah, and that's pretty much it for this solution. Now let's code it up and make sure it passes our test cases. Okay, so let's implement the solution we just saw in the overview. So we need a queue first to just have all of these senator values. So let's use a queue, a double-ended queue, so that we can pop from the front and append to the end. So this is just going to take the Senate characters. And we need two. One is for R that appeared before, and then the other one is for D. And so let's just have D here, like this. Okay. And then now we can just do what we said, while the length of the set for the queue is bigger than 1, so there is more than one party. We pop each time, that's what we do. And then we check if this is a D, then it depends, right? If R before count, right, is equal to 0, that means basically this D is not banned, right? Because there was no R before it, which means we should add it to the back of the queue. And we should say that we found a D, so that for the next iteration, if there is an R, it can know that this D will ban it, right? And so we want to say D before count plus 1. Okay. Now, otherwise, this means that R before count is bigger than 0, right? So it means there is an R before this D that can ban it, right? And so since each player plays optimally, they will ban it. Okay, that will ban it. Okay, and so that means banning it means we don't add it to the queue. We don't. But also, since we used this R to ban this D, we should decrement the R before count because we just used it. Okay, and then exactly similar thing happens for the R, except so we will check for an R and so we will check for an R, and here instead of checking for an R, we check for a D, right? We check for the opposite one for each one of them, and so here just we reverse each one of them. So this means there is a D before this R that will ban, and this means this R is not banned, right? And so this can be just an else if. And now at the end here, we just check the remaining one, which we can do with pop left. This is the winner, right? Because this is the remaining party that was left left at the end. And so we check, we just return dire if the winner was D. Otherwise, we return radiant. Okay, and that should be it. So if we run this, submit. and that passes. Now, one thing that is not ideal here is that this is very repetitive, right? We are using the same code over again 2 times. And so one way we can do this is actually, a clever way we can do this is, instead of representing those with 2 variables, we can just represent them with a list. So let's call it before count, okay? And let's have 0, 0. So basically we will have R mapped to 1, and we will have, D mapped to 1, and we'd have R mapped to 0. The index, right? Index and then index. And so we need that to be represented here. So I'll just say it's 1 if x is equal to d. Otherwise, it's 0, which means for R, it's going to be 0. So this is basically this mapping here is that d is 1 and R is 0. Okay. And now we can use the same logic, right? So now the good thing about this is that for R, right? So from D, which is 1, to get R, it's just 1 minus 1, which is basically just 1 minus D. Okay? And similarly for D, then it's, since R is equal to 0, then if we do 1 minus 0, it would be 1, which is D, right? So basically what this means is that 1 minus D is going to be equal to R, and 1 minus R is going to be equal to D, right? 1 minus R is going to be equal to D, because D is 1, and so 1 minus 1 is equal to 0, which is R, and then since R is 0, 1 minus 0 is 1, which is D, right? And so this means basically to get D, when we have R, we just do 1 minus the value, and then same thing for R. So that makes the calculation here nicer, which basically means instead of doing this before here, we can just check before count for 1 minus C. And we can remove the check on whether it's D or C, because now we can obtain the one from the other easily. And here, this is just before count for C itself. Okay. Otherwise here, it's the before count for 1 minus C, for the reverse, for the opposite one, right? And now since this is generic, we can remove this. Except here, to check if it's D, we check if it's 1, right? And that should be it. And here actually we can just use cube.popleft, and this solution should be a lot simpler. Let's see if it works. We just need to close this properly, and that passes as well. Okay. Yeah, so that's pretty much it, I think, for this problem. There's another solution you can do using 2 queues, but I think this one is just easier to come up with if you were to solve the problem on your own, than the 2 queue approach. Yeah, so that's pretty much it. Please like and subscribe, and see you on the next one. Bye.